All right, everyone, let's get started. We have a short discussion today. So, are there any questions before we get started on the first question, on the first one? All right, so the first one is an anonymized proof. We have A, B, B sets, and U is the universal set, and I want to show that if A intersects B equals A, then the complement of A union B is the universal set. I will give you guys about 3 or 4 minutes to work on this one, and we can talk about this. All right, so anyone who wants to take a shot on the first one? How would we start the proof? It's another set proof question, set equality problem. I'm using the anonymized proof. So we know that for a question of proving set equality, we just want to show that they're subsets of each other, which means we should have two can have two claims, where the first claim is we would like to show that the complement of A union B is a subset of the universal set. And then the other claim is that the other way around, that the universal set is a subset of the complement of A union B. All right, so for the first claim, you would just want let X belongs to the complement of A union B, like always, be given. And then we can just directly say that by the definition of the universal set, we know X must be in U. And thus, the claim is true. All right. And how would you gonna start the second one, the second part?
Take an element x contained in the universal set,
Mm-hmm.
and then the universal set is equal to A union A complement.
Mm-hmm.
By definition. And from there, I would substitute A intersect B is equal to A to use the hypothesis.
Yep. So we can just, we know that X is in a union A complement, and then X can be either in A, or X can be either in A complement. Is this what you're trying to say, or?
Yeah, that's exactly what I was going for.
Okay, yeah. And then, where the case if X is in A, okay, so why don't we start the X is in complement of A. So if X is in complement of A, then we know by the definition of a union, X is just in the complement of A union any other sets. So, well, this just implies that the universal set is a subset of the complement of A union B. So for the case where X belongs to A, there's another statement that we haven't used, is the assumption here. So given A intersects B equals A, and we know X is in A, so this actually implies that X must be in B, because this one, the assumption right here, actually means that X actually means that B is a subset of A. And then from this point, we can say that thus by the definition of union, X is in the union of these two. And then thus the universal set is a subset of the union of A complement and B. All right. Any question on this problem?
Yeah, you said B is a subset of A. Would be the other way around, that A must be a subset of B?
Yeah, sorry. Yeah, you're right. Yeah. So if we just draw the Venn diagram, this should be like this, where this is A and this is B. Yeah, you're right. So given that A intersects B equals A, that means A must be a subset of B.
Cool, thank you.
All right. So the next one is a set contradiction proof, and it says we want to use. It would be better if you could use the proof by contradiction to show that the intersection of these two sets is empty. All right, and I will give you guys some minutes to work on this one. All right, so what's going to be the contradiction?
I used an element-wise proof, so I took an element that is, I assumed there was an element in the intersection of the two sets, and set the definitions equal to each other, and used algebra to prove that there is a contradiction.
Yep, that sounds like exactly what I would do. So, like you said, we can have we assume there exists some element, let's say x, belongs to, well, x is the, like the common element they share. So by the definition of these two sets, we know that x equals to the 2k plus 1 and equals to 4, we should use another variable since we don't want to, since it doesn't imply that right here they are the same k. All right, and then yeah, we're just gonna do some algebra to eventually show that we actually reach a contradiction. So if we if I just, let's see, we just rearrange this, and then minus 2k on both sides, I have 4l minus 2k, and then if I take out the 2, that's 2l minus k, and then by closure, that just equals to some other variable, let's say p, and then divided by 2 on both sides. And clearly this is a contradiction because we already defined that right here p has to be a natural number. So we can see thus the original statement is true. The intersection of these two sets, it's empty.
I had a quick question about just the domain of P. Can we say that it's in the naturals, or would we have to say that that would be an integer?
Yeah, good question. I think in this case, to be more precise, it should be integer. Yeah, because the 2l minus k can be a negative integer, so can be a negative number. Yeah, it would be better to say that p belongs to all integer. All right, any other question? Cool. So the next one is a power set problem. And just prove that the intersection of these two power set equals to the equals to the A intersects B, the power set of this. So I will give you guys some minutes to work on this one. Okay, so let's do this together. So I wanted to prove this power sets are equal. So we're still going to show that they're subsets of each other. All right, and then to start the first part, we want to maybe I just use C. That's better. We know that C is an element which belongs to the intersection of these two power sets. And C is actually a set. And just by the definition of intersection, we know that C must belongs to the power set of A, and C also belongs to the power set of B. And what does this two imply about the relationship between C and A and B? So if we know that C belongs to the power set of A, then that just implies that C is a subset of A. And then similar for the other one, that C has to be a power set of B. Sorry, has to be a subset of B. And that's by the definition of the power set. So we can, which this gives us that C is a power set of, sorry, C is a subset of A intersects B. So C is an element of the power set A intersects B. All right, and this is the first part. So for the second part, we're still going to start with that C belongs to the power set A intersects B. And then by the definition of the power set, we know that C is a subset of A intersects B. And by the definition of intersection, we know that C belongs to A. C is a subset of A, and C is also a subset of B. All right, and this should imply that C is an element of the power set A and an element of the power set B. And then thus C is an element of the union of these two power sets. Sorry, intersection. All right, and thus you can say they are equal to each other. Questions?
Can we do a proof by contradiction?
Are you just
With this
assuming
problem.
that they are not equal to each other?
Yeah.
Do you want to explain how would you do that?
Yeah. So what I did was I supposed the opposite, and then that would mean there exists an element X contained in the power set of A intersect B, such that X is not contained in the power set of A intersected with the power set of B. And then you would let X be equal to the elements, the pair AB By definition, A, B is contained in A intersect B, or sorry, A, little a and little b are contained in A intersect B. But that would imply that little a and little b are both in A and in B. But then their pair would then, by definition, be in the power set of A and the power set of B, which implies X equal to the pair AB is contained in the intersection of the power sets. And that's a contradiction.
So I think, are you talking about like the pairs like this AB?
Yeah.
So for this, so this one actually belongs to the A cross B.
Oh, okay.
Yeah.
Oh, yeah. Okay, so I would need to amend that. That makes sense.
Yeah, so this one only occurs when you have like A cross B. You would just do the cross product with all the elements. That's where you have the pairs. But for this one, you would just have like a single elements.
Okay, that makes sense. Thanks.
Mm-hmm. All right, so the next one is a Boolean algebra problem. Just gonna use all the properties below to show that they are equal. All right, anyone wants to take a shot on this one?
Sure. So I started with the left-hand side, and then I rearranged A plus B to B plus A using the associative property. And then using the distributive property, I got A plus the product of, or I'm sorry, B plus the product of A and C. And then the associative property to just,
B plus the product of A and C?
B plus the product of A and C.
Oh, I see what you mean. Okay. Sorry, like A and C, I don't.
Yeah, I think so. Isn't that the distributive property?
Are you? Is that what you have, like B plus?
Yeah,
A
just
dot
like that.
C?
Uh-huh.
I see. So the distributive, oh, you're doing like it backwards, right?
Yeah.
Okay, yeah.
And then you just change the order of the just associative property to get A times C plus B.
Mm-hmm.
And I don't know if you need, or I said associative, but I actually meant commutative both of those times. Sorry about that. I get those confused.
Oh,
The
yeah.
last one would be associative, I guess.
And then which one are we gonna apply? Oh
I'm
yeah,
not
that's
sure.
okay.
Maybe you
Yeah,
need
never
associative.
mind. Yeah. Yep. So that's, I guess that's all we need if you gonna use the reverse of the distributive. So the other way would be I guess would be take a few more steps if you just view this as a whole, like as this one as P and this one as Q plus R, and then you're just gonna apply this way of the distributive, and you're still gonna have the same you're still gonna get the same result. All right. Any other questions on this one? So this is actually our last question for today's discussion. So if you don't have any other question, you're free to leave. And yep.
Well, thank you.
Thank you.
Mhm. Have a nice day.
I have a quick question. I want to ask a question about the homework.
Sure. Which one?